Hello, and welcome to another episode of Risky Business. Uh, I have a lot of ideas that have been swimming around in my head of things we can do with the High Five One. One of the things I was thinking about was I took a little look in my Linux book, and I was reading about terminals, and it has some example code in there of how to basically set it into raw mode, which there isn't actually like a raw mode. You have to go through and tweak some stuff, some various flags to do the equivalent of what on older systems was an actual mode. But so I'm thinking something that would be interesting to do would be to set up the terminal device that gets created to be in raw mode, and then have a program open a file descriptor to it, and then basically like do a polling read. And expose devices on our system to the High Five One that way. So there'd be a little program running on our computer that we'd write that puts the High Five One's terminal into raw mode and then just talks to it. And it would like provide channels to let the High Five One like write audio to our speakers, or maybe it would open a little window and provide the ability to write like pixels into the buffer and get them to display on the window. We could get it to do sockets this way, and maybe connect to the chat. So we could do all kinds of fun things with that, I'm thinking. And then some other things we could do would be to implement a fourth on it, because I know those are really simple to implement, and you can get some pretty high-level features with very little code. So that would be pretty fun to do. And maybe like a brainfuck interpreter. Those are always fun, and they're pretty simple. I think that would be kind of fun too. So basically I have a lot of potential projects that we could do, and some of those we would definitely be doing in assembly. Setting up the thing on the computer side would be in C, of course. But we still need to do Milton. We still need to finish our lines. So, like, I'd really love to just like do complete High Five One streams for quite a while. I think that could keep us busy for quite some time. But we really should finish up the Milton stuff first. So I want to get that out of the way as soon as possible, basically. But before we do that, I've been saying I'm going to package it on the AUR, and I still haven't gotten around to doing that. So I think we should do that today. Get the Freedom E SDK packaged for the AUR. But one thing I want to point out before we start is beautiful insofar as you wrote that pretty fast. But yeah, so I was talking on the forums, and it was mentioned to me that you know how last time when we tried to do the Hello World, it complained about missing interrupt handlers. Um, and so when we modified the program, we ended up using the demo GPIO program because that one worked. It turns out that when you switch projects, the make files, you need to do a make software clean before building a different program. So that's what the problem was. So I tried that off stream. So if you do the software clean and then try to build the hello world, it works just fine. So I think currently the program I have on my High Five 1 is just a hello world that slams Miblo High Five. But I don't have it plugged in right now, and we don't really need it plugged in since we're just going to be packaging for the AUR. So I want to open up a few tabs, I think. So first of all, when you want to take a look at the AUR packaging guidelines, I know we're going to probably want to put the Freedom E SDK in the opt directory. That's /opt. But the one thing about that is that, so let me see here. Where do I have Freedom E SDK? Here it is. So it searches for the software to build under the software folder, and I'm not sure if there's an easy way to configure that to look somewhere else. But if we just throw it in opt, it's going to be looking under opt/freedom ESDK/software, and we're not going to have write access to that, I believe. So I'm not sure if we can like modify the permissions to allow the user to write to that folder, or if that's a bad idea, or if we can maybe configure it to have a folder like in the home folder that we can do our programming in. And then another thing would be, it would be nice to have wrapper scripts so that you don't have to do the make files directly. But I think starting out, we might just want to throw everything in opt and call it good, and then talk to people on the forums and see what they want. So let's look at this documentation here. I know there is a page on creating packages. This isn't the one I'm thinking of, though. There's one that has like guidelines, and it has an example package build. Here we go. So I am going to go over here, and I guess we should just how do we want to do this? So I think I'm going to go out of this folder and make a new folder. So I'm going to move the Freedom ESDK to there, and then I'm going to make a new folder called Freedom E SDK. And then I'm going to write a package build. So we're going to copy this. So maintainer Mio Iwakura. So we're just going to say something along these lines. And I'm just doing it that way to prevent spam bots from scraping it. And sending me emails about how some prince in Persia or something wants to send me lots of money. So the package name is going to be Freedom E SDK get. Now version. What do we set for version when it's a get package? Because I looked at the repository and they haven't tagged any releases. Okay, so there's this package for function. Okay, so here's what we want. Okay, so there are prototype files in user share Pacman. So let's take a look at those. So these ones would be more up to date. So we're going to copy this one right here. So the package name is going to be freedom ESDK get. They still just say version here. So I'm going to ignore that for that. The description is going to be let's go to the Freedom SDK and see if they have a good description for it. I kind of want to say something about the high 5 1 there in there too, though, because I want it to be searchable. Like if you get the high 5 1 and you don't know you need the Freedom E SDK, and you just search like high 5 1 on the AUR, I'd like this package to show up. I don't think there's tags, so we might need to kind of rework the description a little bit. So I'm going to say SDK for developing on the risc-v Freedom E platform. And I'll maybe say high 5 1. Something like that. Architecture, I'm pretty sure it supports both x86 and x86 64. So we're going to say all. Or maybe we want to put them with commas in between. Oh, there's already a package, Miblo? I didn't realize that. So I guess we don't need to package it. Someone beat me to it. Thank you for pointing that out, Miblo. That saves me some work. So I'm going to point this out on the forums. And then we will do Milton today, I guess. So let's see here. Is this the same guy? Yeah. So so that should be good. Let's close this. I'm going to get rid of this split here. So I don't need this terminal open. So let's fire up Milton. So I believe we left off, we came up with this equation. And it looks like that simplifies to negative 2p over width and height plus 1, right? Because if we distribute minus 1 to both. But we're not going to trust my math skills when we can have a computer do it for us. So we're going to go to Wolfram Alpha and let it simplify it and make sure we're right. So we're going to say 2 over, we'll call it A minus 1 that, okay, use it as a variable instead. So So they simplify it to 1 minus 2p over a, so we're going to go with that. So we are going to grab our eraser here and say so these are the conversions we have. And let's see, why were we doing that? So let's open up the source. So what file were we in? Platform Linux, maybe? Or no, we were doing something with rendering. Where were we doing that? hardwarerenderer.cc. Okay, so we're converting pixels to screen space to OpenGL space. With these conversions. So right now we're drawing a line. We're just drawing it right here. But we want to draw a lot of lines. Okay, so I defined a line spacing. So let's start at the top and then go down by that many pixels. So here, I'll make this a just a constant so it's scoped properly. Now, do I have paper anywhere? Because I want to compare the spacing to actual notebook paper. So let me find some paper real quick. Okay, I have retrieved a piece of notebook paper. Maybe we should make the lines blue too, to match actual notebook paper. It's just a real subtle light blue. Notebook paper blue line color. I just want like a value that's close to the actual color. I guess cyan would make sense. $35 to 40% of cyan only. $3399FF Miblo. Let's give it a try. So right now we're doing color for F, but let's change it to UB, and then we're gonna say 0x 33, 0x 99, 0x FF. And then this would be 0x FF. So I'm going to make that. Yeah, that looks good, Miblo. Thank you for the suggestion. Now we are going to do our vertices. So I'm taking this one step at a time. I would actually put them, like, this isn't how we're actually going to place them. But for now, I just want you get the line spacing right. So we want to figure out what this line spacing is in 0 to 1 space. So we're going to say conceptually we have a vector that's at 0 on the x-axis and 42 down on the y-axis. Now width and height, that's the width and height of the window. So do we have that? I'm not passing that in, so we're going to want to pass something in to get that. So for now, I'm just going to pass in I32 view width, I32 view height. Let's make this I32. So, first of all, let's center this line that we have right now, and then to calculate the pixels, that's going to be so 1 minus 2p over width and height. So I only care about the y-axis, so I'm going to say 1 minus 2 times 42 over the height. So let's just do this in place. So 1 minus 2 times 42 divided by the height. So then we're going to say GL vertex 2f -1, and this is going to be line spacing. And that'll be like this. And let's see how that looks. Whoops. Oh, whoops, we need to update the call site. So we took the width and the height, right? Yeah. Oh, right, I'm calling it twice. I don't see a second line. So it rendered off the screen? Oh my. Floating point exception. What happened there? You know what? These need to be floats. So we still don't have a line on screen. but we don't have a floating point exception at least. So I guess we should figure out what our actual value for line spacing is getting calculated as. So printf so what's the one for a float? Oh wait, I'm making that in I32. Okay, there we have a line. It's way up there though. Interesting. Okay, yeah, that makes sense because I'm saying line spacing is 42 pixels down from the start. So if I actually wanted to put it near the other line, well, I'm a little bit confused. So it makes sense that this would give you that location. That much I understand. But now I'm thinking like, so if I have one line, so let me start up Milton. So this line up here is the one that we just drew, and I said that line spacing is like I imagined it as a vector from the start of the screen going down 42 pixels, and that's exactly what we have. So that makes sense, right? But now this line I put in the center, which is 0, 0, right? So if this line is at 0, and I want to have another line 42 pixels away from it, right? Then how do I say like this much down? Because wouldn't it be like well, I guess the thing is, because of the way we're calculating this, what we're actually doing, so OpenGL draws from the bottom up, right? So it's actually like this right here that we're drawing. So maybe I should use the x conversion because that goes the other way. So if I do the x conversion, it would give us this distance right here, which is what we want. So I'm going to switch it to the x conversion. Yeah, so now we have the line on the bottom. But the thing that's weird to me about this is, like, if I want to draw, I guess I shouldn't be thinking about the origin, should I? So, like, if I draw another line, and I move it over by 2, now which direction is that going? So that went the wrong direction. But if I said line spacing minus line spacing, that would be 0. And that would be the origin that we drew up here. So would it be like divided by 2? Or maybe we have to do our calculations in screen space. So what I'm trying to do is, like, draw a bunch of lines that are line spacing distance apart. So I'm saying that the line spacing is 42 pixels. And so, like, if I say I want to draw at the bottom of the screen 42 pixels up, right? That's what I've done on this line right here. And then I'm saying, okay, now I want to go 42 pixels up from that. So I guess you have to do it before you normalize it, right? I'm not seeing any other way to do it. So let's go back to the Y conversion and draw top down. So I think actually I want this to be 42 and then an int. And then I'm going to do a for loop. And I'm going to say like I equals 0. I is less than or equal to, or I guess I'll just say less than view height. I plus equals line spacing. And then we're going to draw at 1.0 f minus 2.0 f times I divided by view height. Okay, so now we have paper. Now I want to compare it and get the proper size. So 42 is too big, but it's pretty close actually. So I'm going to try taking like 10 pixels off. So let's see how that looks. So it's a little bit off still, but I think that's close enough. So let's make it like an even 30. So that actually looks too small. Let's try 35. That's actually really close. Still not quite right, but pretty close. Let's do 36. I think we're going to go with 36. That looks good enough to me. So, I'm going to call it a day here. And tomorrow we're going to actually make this sync up with the canvas. So right now, um, if I move the canvas around, you can see that the lines don't move with it. And we're going to change that. We're going to make it so the lines move with the canvas. So thank you everyone who watched today, and thank you everyone who watches on the YouTube archive, which is at risc-v. And you can follow me on at HMN_risky on Twitter to get updates on when I stream. So once again, thank you, and stay risky, everyone.